Hey everybody, this is what you've been waiting for. This is the extra credit for Q1. There is no due date on this, but we want to go ahead and get it done because at the end of the year I'm going to give you some more extra credit. So let's go ahead and get this done. Now what I want to explain to you is this is a three-parter. There are three different packets. So you need to make sure that you have the right packet with the right video, because it's going to be the same as always, where you've got to show your work on both sides and you've got to watch the video. Okay, even though some of this doesn't say it, but that's it. We're going to show our work on both sides while watching the video. Each one of these packets, I'm going to give a lot of extra credit here. You can get up to, for each one, 5 points added to a test, 5 points added to a quiz, and 5 points added to an exit ticket. So if you multiply that by 3 of these, you're looking at 15 points added to test scores, 15 points added to quiz scores, and 15 points added to exit tickets. Okay, so that's a big punch. So you want to really pay attention and make sure you do well on these, okay? All right, this is the one that says Part 1. We should have the volume up. We should not have earbuds in, nothing like that. So if you're listening, I want you to write volume up right here next to Part 1. I want you to write volume up, okay? So here we go. Average rate of change. What is average rate of change? It is really the average slope. Okay, I guess I should have wrote that here. Average slope over a specific interval. Okay, and why is that? Because when you are dealing with something that is not linear, the slope is different everywhere, so they have to specify an interval. Okay, so this is pretty easy here. They give us a table, so we want to use the ordered pair where x is 2, so we're going to use this ordered pair, and we want to use the ordered pair where x is 4. Okay, so now we've got our ordered pairs. We're going to do and the BBBS. So down, up, down, up. Okay, when I simplify the top, I think I get negative 24. When I simplify the bottom, I get negative 2. So my average rate of change is 12. Okay, you're going to show your work over here. Okay, sequences. I guess depending on how quickly you do this extra credit will determine if we've gotten to this or not. We're going to get to this next week. Next week meaning it would be March 24th, okay, is when we're going to start sequences. So some of y'all, if you're doing this quickly, may get an early start on it, okay? A sequence is a series of numbers that has a pattern, okay? Notice it says the sequence below shows the total number of days Francisco had used his gym membership over the weeks 1, 2, 3, and 4. So here they are. He did 4 days the first week, 9 days the second week, okay, 14 and 19. As of the 4th week, he had 19 total number of days at the gym. So, assuming the pattern continues, which function can be used to find the total number of days Francisco used for his gym membership by the end of week N? Okay, so these are formulas, okay. Arithmetic sequences have the pattern is add and subtract. And hopefully we know by now that adding and subtracting is a linear model. Okay. Geometric sequences have a pattern of multiplying and dividing. So a geometric sequence is the same thing as an exponential model. So now let's look at our pattern. How do we get from 4 to 9, 9 to 14, and 14 to 19. We add 5 each time in this pattern. So when we're adding, this is an arithmetic sequence, okay? The given problem above is arithmetic because the pattern in the sequence is adding 5, okay? Now, write the function, find the 50th term. Okay, again, if we haven't gotten to this yet, you're getting a first look at it. For an arithmetic function, it looks like this. A sub n equals a sub 1 plus d parentheses n minus 1. Okay. This stands for the first term in the sequence. The value of the first term in the sequence. That's why there's a little 1 there. This stands for the common difference, and that is a 5. Common difference is a 5. This is your pattern here. Okay, if it was subtracting 5, then you would put minus 5 here. Okay, N stands for the term number, and we'll get to that in a minute when we get down to this next one. Okay, so to write this function, we know that our first term is 4. The value of our first term is 4, so we're going to put a 4 here. And we know that our common difference is 5. So the function looks like this. A sub n equals, we're going to put our first value of our first term, which is 4, plus common difference, the pattern is 5, parentheses n minus 1. Okay, so this is our function. We can use this function to find any term number we want. So for instance, 4, 9, 14, 19, you can keep going forever. And if you wanted a particular value for a particular term number, all you have to do is plug in the term number. So that's where we get this second part. Find the value of the 50th term. So they're letting us know n is 50, and we plug it in right here. So A with the little 50, that just says we're getting ready to get the value of the 50th term, is 4 plus 5, and we're going to plug a 50 in for the term number. Okay, and now we can just put this in the calculator. So we have 4 plus 5 parenthesis 50 minus 1, and the value of the 50th term is 249. The value of the 50th term is 249. I'm also going to show you another trick. You can go under y equals, clear out anything that's there, and you can put this function, and instead of n, use an x. So 4 plus 5 parenthesis, use an x minus 1. And now we're going to go to our table, second table. And what I want to show you that's really cool is it is listing all your numbers. Your first term is 4. Second term is 9, 14, 19. And if you'll notice, it gives you all your terms. So if this pattern continued, the 15th term, the value would be 74. Notice this asks for the 50th. The value of the 50th term is 249. All right. Okay, you guys are going to do the right-hand side here. Show your work just like I did here. Okay. Let's go ahead and draw a rectangle next to find the average rate of change if you're listening. Okay. All right, still doing sequences here. We need to know what the pattern is here. Okay. And notice it's a word problem. The sequence below shows the total number of rabbits in a particular sanctuary each year. So the first year there were 4, by the second year there were 12, by the third year there were 36 rabbits, and by the fourth year there were 108. So what is the pattern of what we're doing here? I'll remind you of how to check patterns. Okay, you can do second minus first, third minus second. That's not the pattern, so it's not adding and subtracting. To check multiplication division, we divide. Second divided by first, third divided by second. We can do it one more time. Fourth divided by third, and notice we have our pattern. Our pattern is multiplying by 3. So this is geometric because the pattern for geometric is multiplying and dividing. Write the function. Well, for geometric, the function looks like this. A sub n equals a sub 1 parentheses, I think it's an R, can't remember, raised to the n minus 1. And if you remember on the previous page, we said multiplying and dividing is exponential. Well, look at your function. It has a power of n minus 1, and I'm going to put that in parentheses because if you're plugging a number in, that would need to be in parentheses. So, again, a sub 1 is the first term in your sequence, so that would be 4. R stands for the common ratio, which is your pattern, multiplying by 3, so that goes in there. So to write this function, it would be a sub n equals the first term, value of the first term in the pattern, which is 4, times your common ratio, which is 3, raised to the n minus 1. This is all an exponent. This is all a power. Okay. Now we're going to use that to find some information. What is that information? Find the total number of rabbits after 11 years. So this is my n that gets plugged in. This is my term number. So it's when we plug it in, it's going to be 4 parentheses 3. We're going to raise it, and we're going to use a parenthesis to the 11 minus 1. 11 minus 1 and close the parenthesis. Okay, so let's enter that in the calculator. 4 parentheses 3, close the parentheses. We're going to raise it to a power, so I need a caret key. We've got to open a parenthesis here to type in 11 minus 1. If you know that 11 minus 1 is 10, then you can just type in 10. It's going to give you the same thing. Notice these are growing very quickly because they're exponential. So after the 11th year, there are 236,196 rabbits after the 11th year. 236,196. 236,196. Okay, now you're going to do one over here. Okay, all right, exponential functions. You're going to get a first look at those as well because we have not gotten to this yet. So you're going to get a first look at that. The value of a home increases by 2.5% each year. Y'all, anytime an increase is in a percent, you know that is exponential. Okay, it's exponential when it increases by a percent. Okay, if the home was purchased in 1990 for $85,000, write an equation that can be used to determine what the value was in 2005. Okay, so linear model, and this is actually up on a flip chart. Not linear model, it's exponential. It's not linear. Okay, how do we know? Because it's increasing by a percentage. Also know that if it is, let's say something is doubling or tripling, That's like doubling is like multiplying by 3, or 3 would be your factor, tripling, halving, all of that is exponential, okay? Okay, now, all of these questions are about the formula, okay? The formula is y equals a parentheses 1. We either use a plus or a minus r raised to the time, and again, this is up on a flip chart and we're going to get to this, we just haven't gotten to it yet. So this right here is my initial value. Okay. This right here is my rate, and we have to take our percentage off of our rate because this is our rate. So we'll have to get the percentage off when we put it in there, and this stands for time. So now when it says do we want a plus or a minus sign, they're talking about this. And basically, we look for this keyword, increases. Increases is a plus sign. If it says appreciates, that means goes up. That would be a plus sign. Decreases would be a minus sign, or depreciates would be a minus sign, okay? So it's going to be a plus sign because it increases. So we're going to use a plus sign, okay? How do you know? Because of the word increases. Okay? So now we've got our formula. Y equals a parentheses 1. We need a plus sign, r raised to the t. We're going to plug into the formula. So the initial value, notice it says it was purchased for $85,000. So that's going to go here. Okay, 1 plus the rate. Okay, we're going way back to maybe 6th or 7th grade. I have 2.5, and the way I do that is I divide by 100, because percent is the same thing as multiplying by 100. Also, some of you guys may remember that basically dividing by 100 just means move the decimal back 2 places. Move the decimal back 2 places. 1, 2. And fill in with a 0. Okay? So we're going to have a 0.025 here, raised to the t. Okay? And now, if I want the value in 2005, we need to know how much time has gone by. So how much time has gone by between 1990 and 2005? Well, what we do is we just subtract. The year 2005 minus the year 1990 is 15 years. So we're going to plug a 15 in where the t is. So here we go. 85,000 parentheses 1 plus 0.025 raised to the 15 years. And now we're going to plug that in. 85,000 parentheses 1 plus 0.025, close your parenthesis. We need a caret key and 15 years. So by the year 2005, a home that was purchased for $85,000 is now worth $123,105.34. $123,105.34. Okay? All right, now you're going to have to do that over here, and I'm going to help you out by circling this word here. And you're going to need to go back and look at what we said about that, okay? Need to also do this one, and if you're listening, let's go ahead and let's draw a star next to the word sequences. Okay? All right. This is going to be a little bit of a review for you because we just got done with quadratics. What is your A? That would be the coefficient in front of the x squared term. It's 1. What is your B? That's the coefficient in front of your linear term. It is -2. And C is our constant. It's -8. Okay. To find, and notice there's 4 blanks because these 4 words are mean for you to do the same operations to find solutions. So to find the solutions, and hopefully we know that roots would be the same word, find the roots. It could say find the zeros, that would be the same thing, and it could say find the x-intercepts. All 4 of these require you to do the same thing. You are going to factor and solve, okay? All 4 of these words, you're going to factor and solve, okay? So we're going to go ahead and come over here. We'll do our 2 by 2 box. First term, first box. Last term, last box. Multiply them together. The middle term goes here. So I need my magic numbers that multiply to get to -8 and combine to get to -2. They are going to be, let's see, -4 and +2 are our magic numbers. And let's put x's here. And now we need greatest common factors. Here it's an x, here it's a 2, down the first column it's an x, down the last column it's a -4. Okay. So we're going to do x minus 4, and x, it's going to end up being +2 because my signs are different, equals 0. Okay. We are not going to do vertex formula here, so I'm not going to worry about that right now. Okay, we'll just do our factored form. Okay, we need to set each factor equal to 0 and solve it to get our solutions, roots, zeros, x-intercepts. Okay, so we're going to add 4, and we find out one of my x-intercepts is 4. We're going to subtract 2. We find out the other x-intercept is -2. Okay, so now we're going to graph this. So x-intercepts. This is my x-axis. One of them is 4. Okay, so x-intercepts are 4 and -2. Okay. Okay, which way does this open, up or down? Well, remember, if my A, the coefficient in front of the x squared, is positive, it's going to open up. Why? Because A is positive. The y-intercept, let's not forget, the C is my y-intercept when it's written in standard form. So my y-intercept is -8. So now we're going to graph this thing. I'm going to put my y-intercept on here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And, oh, now I know why I needed my vertex formula, because we do need our vertex. Remember, the vertex formula is, to get the x part of it, it's opposite of b over 2a. We got to find that, because we got to know where our vertex is. So, opposite of b over 2a. So let's go ahead and find our vertex. It's a good lesson anyway. Okay. Opposite of b, if you look up here, is going to be a +2 divided by 2 blank, opposite of b over 2a, and a is 1. So when I multiply the bottom, I get a 2. When I multiply the top, I get a 2. So the x part of my vertex and the axis of symmetry is 1. Okay? So in other words, there's an imaginary line here, x equals 1. That is my axis of symmetry. Okay? So it's going to be symmetrical around that dotted line. And we remember last week we found out that if I want to find the y part of the vertex, I plug this in. So I'm going to plug in. So what does it sound like? Blank squared minus 2 blank minus 8. blank squared minus 2 blank minus 8, and we're going to plug the 1 in. 1 squared is 1, that's a 2 minus 8. When I do the math, let's see, it's -1, it's -9. So this is the y part, and this is the x part to my vertex. My vertex is 1, -9. So let's graph that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So we know this is where it turns. Okay? And now we can sketch the rest through the points. And that's my parabola. Okay? So you're going to do the same thing over here. Okay? For the vertex, remember, opposite of B over 2A, and then you're going to plug that in to get your vertex. Okay? You could almost, if it helps you remember, make an ordered pair out of this, and then draw an arrow and say plug in. So plug into the function to get the y part, or the y coordinate of the vertex. Okay, so you guys are going to do this one and you're going to graph it. All right, part 1 is done. If you're listening, I want you to flip over on the back and I want you to write part 1 is done. Y'all have a good day.